In this next part, I'll be showing you how to connect the potentiometer to TouchDesigner. So let's go ahead and start with patching this up. I'm going to go ahead and just insert this onto my board. I want to make sure that it is bridging this middle gap here. So make sure that is firmly set in place. So if you remember the potentiometer, these pins represent specific things. So the leftmost pin, that's going to be the power pin. So I need to make sure I am connecting this left pin in series with my power rail on my board. Then on the middle pin, this is the signal pin. So this is going to be connected to the pin A0 on my Arduino board. So I'm going to make sure I patch this up properly. And A0, I know that this is 2 over from the voltage pin. So I'm going to connect that 2 over there. And the rightmost pin on the potentiometer, that is going to be the ground pin. So I want to make sure I'm connecting this in series with my negative rail on my breadboard. Okay. There's also a diagram I've included in the tutorial guide. This is a virtual diagram using Tinkercad, so that may be a little bit easier to follow along with as far as this patching process. Just know the left pin is going to the positive rail, middle pin is going to pin A0 on the Arduino, and the right is going to the ground rail. And that is a setup. So let's go ahead and dive into the code. So in the Arduino IDE, let's go ahead and once again, we need to set up the pin connection. So I need to first create a variable, const int. So I'm going to call this pot pin, and this is going to equal A0. Next, I'm going to go ahead and create a variable for the pot val, or the pot value. And then in setup here, I'm going to once again use my pin mode function to tell Arduino how to use this pin, whether it's an input or an output. For analog pins, this is going to be an output. So I'm going to specify which pin, and this is the pot pin, and this is going to be an input. Going down to the loop function, next I need to read the value of the pot pin. And I need to store that value into my pot val variable. So pot val equals. So because we are connected to an analog pin, A0, I need to use my analog read function. And I'm reading the pot pin value. Last but not least, I'm going to make a new line underneath my button val. So order does matter here, so I want to make sure I'm putting this below my button val serial println. I'm going to, once again, type out serial.println. This time I'm going to print out the value of the pot val. So remember, we need to print this to the serial port so that TouchDesigner can grab it. If these are not present, if these lines of code are not here, then we're not going to have any communication into TouchDesigner. So once that is all set, let's go ahead and let's upload this. Let's upload this update to my board. So I get this message. It says no device found. And if I go to TouchDesigner and I look at my serial, I see that there's no additional value being output here. Right? The potentiometer should be showing me another different value. And just to show you here, when I'm turning the knob and nothing's happening here. So this is a good lesson in this process of how what we need to do when we update the Arduino code. So I'm going to go here to the serial. I'm going to open up those parameters again, and let's just toggle this active off. Turn it back on. We see there's no change here. So let's try to turn this off. And let's try to re-upload this to the board. Again, this is going to be a valuable lesson here in troubleshooting what could happen if this connection is not successfully established. So I'm going to try to re-upload this to my board. So that is done uploading. Let me check out TouchDesigner again. And let me turn the active state to on. And there we go. That seemed to fix it. Okay, so good lesson here. So if there's no update, make sure the active is off, re-upload the code again, and then turn active back on. So now I see two values here. And if I am turning my knob, you can see that second value is changing. So this is a successful connection that I established. If you remember, the potentiometer range is from 0 to 1023. So the maximum I should see there is about 1023. The minimum I should see is about 0. Great. So there are going to be a couple of changes we need to make. Because as you can see, we're only now getting the potentiometer value. So let's click on select. And now we can see I have two lines of values that I need to account for. So in my select, I need to add another line. So I'm going to look at my start row index, and I'm going to actually decrease this by 1. So now I should be starting at the ninth row. Once I do that, I should now see only two rows in my select. The top row is my button, and the bottom row is my potentiometer value. So from here on out, we just need to really just add in another select to grab the value from my potentiometer. So I want to make another branch here. I'm going to add another select chop. And let's go ahead and connect my DAT2 to this other select. And for this select, I want to isolate that second channel. I also want to rename it. So for channel names, I'm going to use channel 2, rename from, so original name, chan 2, and I'm going to call this one pot for potentiometer. So now I should only see that potentiometer channel being displayed. And just to verify, I'm going to turn my knob, and that is affecting that value. Okay, so here I do want to add a couple of things to smooth this out, because we can see how sporadic that value is. It's very jittery. So you don't need to do this part. I just want to show you what this looks like. So I'm going to add a trail chop. And just to have a visual of exactly what's happening in this graph here. So right now, you can see it is very, very jittery. So a couple things you can do here, just to make sure that connection to the potentiometer is firmly in the breadboard, and make sure all the wires are firmly connected. And you can see that it does suddenly drop down to 0 every now and then. But for the most part, it's kind of hovering over this top range here. And I can see the majority of my value right now in this position of my potentiometer is about 900. That is a little bit too crazy for me, right? We can see it kind of evened out there, but then it went back. So there are a couple of techniques we can use to smooth these values out and make it so that it's not as jumpy. So I'm going to move this trail out of the way. And what we could do here is we can use another chop. And this is called the filter chop. The filter chop. So I'm going to connect my select to the first input of filter. And so what filter does is it attempts to smooth the values as much as possible. So if there are any sudden spikes or changes, filter attempts to not account for those and just essentially try to take the average of the values. So for filter, now I'm going to compare this trail to my original one, and we can see that it is a lot more consistent, right? So now it's just dipping between 880 and about a little under 920. Versus over here, we can see that there are dips all the way down to 0. So this, I mean, the reason why these dips occur is there are quite a few, there could be a few different reasons. One reason is there's just a natural noise that happens when you're supplying electrons and you're supplying current to these components. So sometimes these currents have big fluctuations, and even though we don't really, when we're using a potentiometer on the board for other components, we may not see that or may not be as noticeable. Here, when we're actually looking at and breaking down the values, it does become more noticeable. So a filter helps sort of smooth that out and make that more consistent. If you open up the filter parameters, we have a filter, we have an effect value. So this is just how much the filter is working to smooth these values out. If I decrease that, you'll see that that's slowly starting to become more jittery. Versus if I put it all the way up to 1, it's going to just be the maximum effect. And filter width is similar. If I decrease filter width, you see it's going to be a bit more jittery here. If I were to increase it a little bit more, I can maybe get a bit more of a consistent value for that potentiometer. But that's pretty much it. That's pretty much the process of getting your inputs from Arduino into TouchDesigner. And from here, again, it's just business as usual. So you can use these values however you like. And from here, if you want to map these, think about how you would convert the ranges. So using the math chop. And yeah, as always, just make sure to end these chains with a null chop. And you can add whatever you want in between the null. Nulls, again, are good practice to end your chains with, because you map it once from null, and you can make whatever changes you want in the middle, and it won't affect your mapping. Same with the button here. Just add a null there, and you can insert whatever you need in between these operators. Make sure to save your work, as always. Just save, save, save. And that is it. Have fun.